Hi, I'm Alan Ross. I'm the managing editor of APC Media and APC Technologies. We are at the Seagray 2023 Grid of the Future Symposium. And these interviews are with the leaders at Seagray and the leaders of the industry. Hope you enjoy. Our next guest is Chris Root. Chris, it's really good to have you back. I've done, I think, two interviews with you.
Yeah.
One of them was a big Zoom thing that we did. Chris was with the National Grid. Then I met you when you were at Vermont Electric. Now you're retired, but you do a lot of things. Tell me a little bit about, before you got into all of that, why did you even get into the power industry?
So it's an interesting story. When I was 18 years old and going on to college, I was going to Northeastern to be an electrical engineer. I got a letter from Northeastern saying, would you consider being a power engineer? And if you want to be a power engineer, we'll give you a scholarship. A company, your utility, will pay for your freshman year's tuition. And I'm one of five boys.
Yeah.
I was the oldest. I was paying my own way to college.
Yeah.
I'm like, I don't know what a power engineer is, but if somebody's going to pay my tuition, I'm all in. So that's how I got into so I took interviews, I got it, and make a long story short, it was a co-op program.
Yeah.
And I co-op through every job in the utility in my undergraduate.
Who'd you co-op with?
Public service in New Hampshire.
Okay.
I worked in a coal plant. I worked in a line truck. I did every job in the utility I did.
Excellent.
And then I went on to graduate school and moved on. But I got a great grounding of learning what it is. And I learned a passion for it. I love it.
Yeah. The different jobs that you've had at the Grid and then at Vermont Electric. When I met you at Vermont Electric, there was change that you all, I was surprised that you did so much solar and so much wind, and you did some very forward-thinking things that were happening there. You told me before we started that you finished everything you wanted to finish there. What were some of the things you finished?
So we took on a lot of asset management, asset work that needed to be done.
Yeah.
We had a significant program of rebuilding transmission lines, substations, but also we had a very high level of renewables connected to the distribution system. And as a transmission operator, we were trying to, how do we take this information, or what information do we need to run the grid? So we developed strategies. We had a very large fiber optic network. Okay. And what we did is we pushed that out to the distribution area so we can start collecting renewable information to use for operations in the control center.
Wow.
That was a major effort and a major strategy.
Which is one of the problems when, from the old step down. So this is the next serious thing. We grew up with, hey, we generate in bulk, we send it down these large pipelines called overhead, and we go out to a very growing but different stable environment. It's not that way anymore. It's from step down to step everywhere is the way to see it. Inverter-based technology creates harmonics and transients that create it's all a set of problems. We seem to be in a very different state of flux. We're here at the Seagray Grid of the Future Conference Symposium, and the definition I've heard is it's got to be flexible, it's got to be resilient. We need to harden the grid, and you start adding all these things, and you go, that's more change in the last 10 years than we had in the last 100 years before that. Pick anything along there and tell me where you think some of the greatest opportunities, meaning challenges to fix, and or some of the areas where we can make the greatest difference. Pick anything.
So a couple of things come to mind. So the changing mix of generation is significant.
Okay.
So in New England, for example, 10 years ago, we had coal plants that ran every day. Yeah. We had oil plants every day. Today, we would have none. There's only one coal plant left in New England.
Really?
Right. So it only runs in the wintertime.
Yeah.
So we're mostly natural gas based. It's totally changed how we do business, right? From a fuel point of view. But the next step, when you start getting rid of the natural gas plants, now you're going to a much larger level of generation that's inverter based. And that's what I call weather dependent generation. And since you or I don't control the weather, I don't know who does, but that's a problem. And we have to be able to solve that problem. And I haven't heard viable solutions to how to solve that problem of having a large amount of weather-based generation without controlling the load to match it. because we have to match the generation with the load at all times, every second. And to be able to do that is one of our biggest challenges going forward. And that's going to work itself out one way or another. The second thing that I think is a major issue is that we're grossly underestimating the growth in electric usage in the future.
Yeah.
So in the 1960s and 1950s, you would have 6 and 7% load growth, which was normal. Every 10 years, you doubled your growth.
Right.
It was not that. Then the oil embargo happened in the 1970s. Conservation happened. Price of electricity went up. And load growth stalled between 0 and 1%. And we've been there for 30 years. Now, all of a sudden, we're looking at 5-6% load growth on top of generation resources going away, which is a potential train wreck.
Yeah.
If you're not careful.
A potential train wreck. Yeah. We got to solve it.
Right.
That's what engineers do.
That's exactly what we're doing.
We take the train wreck. I want to go. Yeah. I'm going to follow up on that one, but I got to follow up on the earlier one. How important will storage be in solving that intermittency of wind and solar?
Significant. Well, it will play a significant role. Storage will in the gaps that happen on small term changes. So a power plant, 20 megawatt solar panels, 120 acre solar plant. When a cloud comes by and over it, it drops to 50% capacity.
Okay.
So very quickly.
Yeah.
So that's a perfect place for storage to keep the output up. Right. So then the grid operator or the people that are asking for the generation have a more reliable output. So I do think storage is going to be tied to that, those type of changes dramatically.
Right.
The same thing also when we come to frequency problems. If we have frequency perturbations, I do think storage can help a lot. It's real power. You can put in the system at the right time to keep the system stable.
Okay. Stable and flexible.
Yeah. Where I get off the boat is our conventional storage technology is limited by how much, lithium-ion batteries you can do, the way we think of it. Right. We think storage, everyone thinks batteries.
Right.
We think there's other alternative storage technologies like pumped storage. Pumped storage can go for days, not hours, right?
Yeah,
you can warm water, you can store it in high depth water. You can energy bank with, for example, Hydro-Quebec, who's got reservoirs the size of our states of water and reserve that to bring back later another time. So we have to be a little innovative when we say storage and not be only think of, we're only going to buy lithium-ion batteries. I'm not sure that is the long-term answer to our storage things. It's part of the solution. I'm not sure it's the total solution.
Yeah. We were at the RE Plus conference last week, 2 weeks ago.
Okay.
And 2 years ago, there were 12,500 people. Last week, a year ago, it was 1,500 people, 15,000.
Yeah.
This year, 40,000 people. And the difference was storage became very prominent.
Yeah.
You had a lot of people. You had several flow battery technologies being offered. You had major corporations now coming up with storage solutions that are utility grade storage solutions. You had hydrogen there. Hydrogen is a storage fuel. And it was thinking out of the box. Water, hydro so hydrogen and hydro. That's what's going to solve it.
I believe that.
It is solvable. And it was good to see the energy and the excitement, because they were really, at the RE Plus, you were mirroring solar and storage. That was the primary focus. Yeah, people putting that solution together.
Yeah, I believe that's true.
So the second thing, now the next thing that you were talking about is when you look at all of the concepts of a hardened and reliable and resilient grid, right? All of the difficulties for the operator, and that's really where the difficulty lies. So much of what they need today is good. Let me take it back. Great data.
Yep.
When they need it. Data science is changing the way we do everything. And now you hear, you're supposed to be doing AI and all of this stuff. You're supposed to let them. Talk a little bit about the future as it relates to data management, because you had to go through that when you had changes in what you did. Talk a little bit about how data. Well, we know it's going to play an important role. How are we going to make it play an important role?
the biggest issue is collecting the data, right? And so one of the big changes that we've had in our industry, things we can do today that we couldn't do before, was the drop in telecommunications costs.
Okay.
That enabled bring back a lot of information to us.
Right.
And we will need to continue to do that, right? So having an AMI system so we know what's going on customer usage. In Vermont, they actually have a smart meter on every inverter. So you know how much generation at all times. Now that is not brought back in real time, but now you start bringing that back in real time, seeing how it's working. You can use it as part of your operations. You go into a control room today, every control room today says how much load is being served, net load and net reactive on a substation feeder or at a substation, right? Yeah. That's what the operator's looking at. But that number that says net load, unless it's at night, is wrong. Because during the night, you have all this negative generation, which is negative load. So that number's wrong. So all of the calculations that we're doing in the behind the scenes to make sure the system is stable are wrong. Because they're using the wrong number. They're using a net number. Yeah. And you have generation, which is not going to react to a perturbation like a load load.
Right.
So I have an issue. So my issue is you need to get that information and then tell the operators and the operating systems that this is the much of net load, but this is how much generation is behind it. Then you know what the real load is. Right. So if the generation drops off, that's the load's got to come on. Yeah. But right now, nobody knows that number.
Yeah.
So your system says, okay, if the generation were to trip off due to a perturbation in the system or a cyber attack on those inverters or something, you don't know what's going to happen. You have no idea.
Oh.
And that scares me, to be honest. So you need to start bringing back that information, give you better data. It makes you think differently, and then you can use the AI to do all things.
Yeah.
Another example, knowing how much your transformer loading is. Every utility has a transformer loading calculation of, that. But when you start having people putting in electric vehicles and never telling the utility, you better really make sure that transformer is not on fire. So, right? Yeah. So 3 neighbors all decide they're going to get Teslas, and all of a sudden the transformer is on fire, right? At night. Well, how did that happen? Well, the utility doesn't want that to happen and fix it at an emergency. They want to anticipate that. They want to be able to deal in a controlled manner. Yeah. But that is a serious issue.
Yeah. When you were at Vermont Electric, one of the things that we actually wrote about was I wish I'd known what I know now, because then I would have done an editorial up front. But you actually turned ratepayers who were consumers into prosumers.
Yeah.
I mean, when you talk about putting storage and having storage, to really think through, hey, our ratepayers can be part of the overall solution when the sun doesn't shine or the wind don't blow. Talk a little bit about that, because that was a project that was fascinating to me.
Sure, I firmly believe this, and I'll give credit. Green Mountain Power, the utility in Vermont, was very forward-thinking. They have over 4,000 power walls, and then in other storage devices, which the power walls they rent as a UPS to the customers.
Okay.
But then they have the right to use that energy storage 3 times a month to control the grid, and they use that for peak demand management. And during peak demand times of the month and annually, they will use all of those devices will come on. They can clap as the load is going up. They'll clamp it off, enjoy it. And I have charts that I've shown at this conference, that versus other utilities where they didn't clamp it.
Yeah.
So you save customers money there.
Yeah.
So everyone saves money by letting us use a device that you're using for a different reason in this application. And this is where customers unknowingly, but really are really helping the stability of the power system. And they get something for it too, because their rate of their rental is discounted, right?
Yeah.
If you recognize that there's going to be socialized savings throughout for the company for customer there.
That to me is one of the most fascinating projects, is it changes the way we think about stakeholders.
Right.
Definitely changes the way we think about the consumer, because you really are. I love the word. I say it over and over again. Prosumer.
Yeah, I know.
It's the consumer that provides value. Last question for you, Seagray. We're here at the Seagray Grid of the Future conference. Tell me about why Seagray. What do you value about Seagray personally, and in your career? What have you valued about it?
What I value about Seagray. It's an organization that's 100 years old, dedicated to the study of power systems. And it's worldwide in 80 different countries. The United States has the largest chapter, or largest committee. But what they provide is technical information and data, not standards, but information that's written by experts from around the world.
Right.
And they create working groups that generate documents that are best practices. They give you information from around the world that I don't know how you gather that, right? So, and they do it on a regular basis. Within 2 years, a working group will be formed and publish what they do.
Yeah.
They regularly publish these documents that are done by not university professors. They're not done in the lab. These are done by professionals in the field that know their business. They're experts in their field. And to get those types of people together to write a document is very powerful.
In 2 years, by
In
the
2
way.
years, right?
It took one of the committees of IEEE 6 years to update the DGA guide.
You're right.
And I don't think it's that much different or better than the one we had. But anyway,
And it's just different from IEEE.
Right.
So it's just run
it's not a
differently.
standards organization.
Right. It's not a
There's you're retired, but you're not retired because you're now you're a consultant to who?
So I work for Quanta Technology. I'm a consultant to industry. I'm the industry advisor. And so I'm doing that. Dedicate time to helping grow Seagray into the organization it should be. And I still work on IEEE too, right? So I do work in both areas.
So what does your wife say? When are you going to retire?
And that's exactly what she says.
Exactly right.
She does. And we do have a plan.
You do have a plan.
We do have a plan. So yeah.
It's great, Chris. Thank you
Thanks
for
for
doing this
your
with us
time.
again.
Appreciate it. Thank you.